Learning objectives B and C, we're going to find the inverse if we're given a relation, which is just a set of ordered pairs, or if we're given an equation. So let's start by defining how to find an inverse, and it's this. We are going to flip the coordinates in the ordered pairs of a function so xy becomes yx. What we did here is we made xy and we made yx. So what's going to happen, there's a reflection over the line, y equals x. This is actually a very key part of when we start looking at the equations of the inverses to realize that y equals x is actually an equation of a line. Okay, well let's start on this problem here. This is a relation, which just means it's a set of ordered pairs. They want us to find the inverse. It's pretty easy. All you have to do, and you might see this as shorthand notation, f of -1 just implies an inverse. I'm just going to flip-flop all the ordered pairs so they look like this. And this is the inverse of our relation. Now they want to know if the inverse is a function. This is great review. Remember, a function says for every single x value I put into the equation or the function or the relation, I will get the same y value. So you're going to have to see if we have multiple x values. Here we have x going in as -5. One time the answer is -3, the other time it's 3. Again, definition of function. For every x, there's exactly only one y. It broke right there. This actually is going to break in another spot. When x is 0, it's kicking back two different answers. Unfortunately, when x is 3, it's also kicking back two different answers. So is this a function? No. It's not necessarily a bad thing that it's not a function. It's not an issue. It just know that this relation is not a function. By the way, if you were to graph this, you could actually tell from the vertical line test. And I'm just going to show you by graphing these two ordered pairs here and here. If I graph -5 and -3, might be right here. -5 and +3 would be right here. Vertical line test says if I draw a vertical line and it crosses in more than one spot, it cannot be a function. So it fails the vertical line test. They want to know if we have this particular ordered pair on a piece on graph paper, where would its inverse reside? Very easy, just flip-flop the x and the y. That's where its inverse would sit. Now they're going to want us to actually find the inverse of an equation, not a relation this time. So one of the things I talked about on the previous slide is, remember, to find an inverse you make x, y. So what you're going to see is this line right here is the line y equals x, which just means it has every ordered pair like 1, 1, 2, 2, 3, 3, 4, 4, and so forth on it. So to find the inverse of an equation, take the equation and make x, y, and y, x. Okay, before I solve this, I'm actually going to graph this particular function here. And you can use your calculator. It's actually going to look roughly something like that. Now, I know this next equation I just wrote is its inverse, and I want to graph it, so we need to solve it for y. To do that, subtract 4 from both sides. We're going to have to get rid of that negative, so divide everything by a -1. So we have -x plus 4 equals y squared. To get rid of the squared, take the square root, which will leave me with y equals the square root of -x plus 4. Now if you graph this, here's what it's going to look like. So there is a slight problem with this, because what should happen is, what we should see is that this red parabola here, and I do have to adjust this a little bit, this side should go more like this. That's a better part of the line, so actually ignore this guy right here. So we have this red part of it. This red parabola, what we're going to see, it's going to flip over that line. Well, we see part of the parabola flipping over the line right there. The other half on this one, you have to be careful. Very common mistake when solving a quadratic equation is a plus and minus. If you do the minus, it'll give you the lower half of this, and it'll look like that. So visually, when you graph an original equation in the red and the inverse in the blue, you will see it flip over the line y equals x. So if you want to check and see if you have the right answer, you can try graphing it to see if it seems logical. Again, it was easy for me to see I was missing the negative half of this graph because the first half just gave me this portion. So be careful. Now, they do want to know if the inverse is a function. We just talked about the vertical line test, so you can actually try that on here. If you were to draw a vertical line on the blue graph, it's clearly going to fail the vertical line test. So on here, it will not be a function. However, look at the original graph. If you noticed, if I drew a vertical line on the red graph here, on any point, it'll only cross in 1. So the original graph is a function. However, the inverse in this case is not. Let's look at one more. Consider this graph right here. Let's look at the parent function real quick. Or in this case, the pre-image. The parent function is more stripped down, so this is our pre-image is in the red. There are some asymptotes there. To find the inverse, this again, be careful. F of x just means y, so let's flip-flop x and y. We're going to have that. Now to solve this one, I want to get this y by itself, so keep this first. Let's move the 4. I'm going to subtract 4 from both sides, which leaves me with x minus 4 equals 1 over y minus 3. Now the easiest way to solve this is to recognize that this is one complete fraction over here, and I can make this one fraction too by putting it over 1. You can actually cross multiply on here, which means I can take y minus 3 and move it up, x minus 4 and move it down. The only time you can cross multiply is when you have one fraction set equal to another. If there had been something else written out here, you can't do it, so be careful. So what I'm going to do is take this whole piece and move it up, take this piece and move it down. It's going to give me y minus 3 equals 1 over x minus 4. This was written over 1, but really I don't need it there anymore. To get y by itself, just add 3 to both sides. So our equation is y equals 1 over x minus 4 plus 3. Now, you can put this in your graphing calculator. Be very careful when you type y equals. That's going to be there. Type this, 1 divided by. You may need to use your parentheses here and then do plus 3 on the calculator. When you graph it, here's what it'll look like. The graph in the blue. You can see it's pretty close. If I were to flip over this line, which is y equals x, you will see the image of it. So when I flip the red graph over the line, the black line, you will actually get the blue graph. So I do recommend when you solve these algebraically, before you keep your final answer, to graph it, put your original graph, the line y equals x, and the new graph, and see if you see the flip happening.